Hello everyone, welcome to Mifratech. Today in this section we will learn about LDR sensor module, which is a light dependent resistor sensor. So mainly it is used in order to detect whether sunlight is there or any light is there or not. So this is how a LDR sensor will look like. So this is what, as you can see, this one is the LDR like it's LDR sensor. So this is the whole is the LDR sensor module. So it will also you can available in this form also. So as you can see, what are the different things are available in this LDR sensor module means. So mainly there will be a light dependent resistor, as I told. This one is the main thing. So it depends on the light only. So this is mainly a sensor which is mainly used in order to detect whether sunlight is there or not. After that, there will be indicator light LED will be there, and there is one more power LED is there. This power LED will be on whenever we provide supply to this sensor LDR sensor module, and this light indicator LED light will on whenever it detects a sunlight. So it has mainly 4 pins: A0 the analog output, a D0 digital output, and the ground pin that in order to provide supply, and VCC. So these are the different things present in this LDR sensor module. So there, as you can see, this one, this pin, like it is mainly used in order to set the sensitivity of the LDR sensor. So we can by changing this one, we can set the sensitivity of the adjuster. You can call it a sensitivity adjuster. So if you rotate it in a clockwise, means it will increase the sensitivity toward the intensity of light. If you rotate it anti-clockwise, means it will decrease the sensitivity toward the intensity of the light. So these are a brief introduction of this LDR sensor module. So mainly, as I told, it is mainly used in order to detect the intensity of a light, whether there is a light or there or not. In order to detect that, we can make use of this LDR, that is light dependent resistor. So it is associated with both analog output and the digital output, as I told, like shown you earlier itself. We can we can get both analog output data and digital output data depending on our purpose. So when there is a light, what happens is the resistance of the LDR will become low according to the intensity of light. So whenever the resistor, the LDR sensor module detects the light, so the resistance of that LDR will become low according to the how much of intensity of light is there. So if it is low, if there is no light, means the resistance will become high. So depending on this resistance changing values, we can measure whether there is a sunlight is there or not, like that. The greater the intensity of means, we can get the resistance of the LDR become very low, and there will be a potentiometer knob which I showed, where we can adjust the sensitivity of the LDR module. So why we have to use this LDR sensor? So the main objective of using this LDR sensor is controlling the light, is to say we can save the electricity. If you connect it to, if you use this LDR sensor, if there is a sunlight, means you no need to turn on any lights in your room or outside street lights. So in that time, whenever it detects there is a sunlight, we can control, automatically turn off those street lights. If there is there is no light, means we can automatically turn off, like that. We can save the electricity. So for that main purpose, we can make use of this LDR sensor. And so what are the different features of this LDR sensor? Means it has an operating voltage of 3.3 to 5 volt DC. So in order to turn on this LDR sensor module, we have to provide a 3.3 volts to 5 volts DC supply. So it has an operating current of 15 milliamps. So there will be 2 LEDs, as I showed, indicating the output whenever there is a sunlight is detected or any light is detected, and one is the power LED. When you provide power supply, that LED will be glowing. So mainly we can adjust the sensitivity of this LDR sensor also. So what are the applications of this LDR sensor? So we can make use of in smart agriculture, home automation, automatic windshield wipers. So there are different application purposes where you want to detect whether there is a light is there or not. In those purposes, you can make use of this LDR sensor. Depending on the sensor values, you can control any street lights or any home automation lights. You can control any different purposes. So next we'll see how to interface this LDR sensor with Arduino, and we'll write a program, and we'll see how the output will look like. So as I told earlier itself, it has mainly 4 pins: a ground, VCC, analog output and digital output. So in this example I am using only the analog output, and so I am not connecting digital output here. So as you can see, VCC I have provided to 5 volts power supply of Arduino Uno, and ground I have connected to ground pin. So analog pin I have connected to pin A0 of Arduino Uno. So this is a simple connection in order to interface Arduino, like LDR sensor with Arduino Uno. Next we will write how a program will look like. So this is a simple Arduino code. So I have connected like in this in the code I have written a LED pin also, because whenever there is a whenever the LDR sensor detected there is no light, I have to turn on the LED. If there is a sunlight is there, means I should turn off the LED. Like that a program I have written. So I have to first define the pin numbers which I have connected. So I have connected LDR pin to a pin number, that is A0 of Arduino Uno. So that I am defining here, that is const int LDR pin as A0, and LED I have connected to pin number 13, that is the digital pin. So constant LED pin 13. After that we have to select, in order to see the output I have to do the setup. So CL.begin 9600, this is the baud rate I have to do. After that I have to define the pin mode. So I am using LED as the output and LDR as the input. So I have to define the pin mode earlier itself. So pin mode of LED pin comma output. So I am LED I am using as the output, and pin mode of LDR pin I am using as the input. So after that we will write our program in the loop here, because this has to be continuously executed. So I have defined one more variable here, that is int LDR status. So I am using, like, reading the LDR pin values. So analog read, so this will read the values from the LDR. So as I am connected to analog pin, so I have to use the analog read. So analog read of LDR pin, so whatever the values it is reading, so that I am storing in the LDR status variable. So I am checking if the LDR status is less than or equal to 200, means so if it is the value is less than or equal to 200, means so it means there is this like there is no like sunlight is there, means the intensity of light is very low. So we have to turn on the LED for that. So if that condition is true, means I am writing digital write of LED pin I. So whenever the LDR read value is less than or equal to 200, so the intensity of light is very low, like it means it is a dark. So I have to, in order to turn on the LED, I am using digital read of LED pin high. So this will turn on the LED. After that I am printing in the serial monitor, like it's dark, turn on the LED, like that. So after that we can also print the LDR status also. So like LDR status means whatever the analog value it is reading. Like that, if the LDR value is less than or equal to 200, I can turn on the LED. If the condition is false, if it is greater than 200, means there is a sunlight is there, means I need not to turn on the LED, I have to turn off the LED if it is on, means. So in that else part I am written digital write of LED pin I am making low, means it I am turning off the LED. So after that I am printing the serial monitor, like it's bright, turn off the LED. So after that we can also serial.println LDR status, means whatever the analog value it is reading continuously, that I am printing, like printing in the serial monitor. Like this, in the simple way you can interface a LED and LDR sensor to Arduino, and you can see how LDR sensor exactly work and by writing this code. So thank you for watching the video. Thank you.